So in this video, we're going to look at using a binomial expansion when we've got a negative or a fractional power. So we'll work through two exam style questions. In our first question, we've been asked to work out the first four terms of this expansion, the square root of 4 plus x, and then we need to state the values of x for which the expansion is valid. So in the EdXL formula booklet, we're given this expansion. This is when we have a constant of 1 and an x term, and this power can be a negative or it can be a fraction. So the first thing we need to do is we need to write this expression using a power. Well, we know the square root of 4 plus x will be the same as 4 plus x to the power of 1/2. The problem we have now is that in our formula, we need a 1 term, but we have a 4 term. So we need to factor out this 4. So if we factor out this 4 term, we'll have 4 multiplied by 1. This will give us a 4 term plus x divided by 4. Because when you multiply a 4 by the x over 4, the 4's will cancel and we're left with this x. And all of this is raised to a power of 1/2. Now we can expand out in this bracket. So we've got 4 to the half multiplied by 1 plus x over 4 to the half. And we know 4 to the half is 2. So all we need to do is we need to expand out 1 plus x over 4 to the half using this expansion. We know that n is the power, this is 1/2, and the x term can map onto x over 4. So we'll substitute these values into this expansion. So we'll get 2 multiplied by the 1 plus this n, which is 1/2, multiplied by the x term, which is x over 4. And then moving on to this part, we've got n again. We've got n minus 1. So 1/2 minus 1 is negative 1/2. And then we've got the x squared term. So x over 4 squared divided by this 2 factorial, which is just 2. Then we need to work out one more because we need the first 4 terms. We've got 1, 2, and 3. So we'll have the n multiplied by n minus 1, and then multiplied by n minus 2, multiplied by the x term raised to a power of 3 over 3 factorial, which is 6. And we'll close that bracket. So now we need to tidy up each of these terms. So we'll have 2 multiplied by the 1. We'll multiply these two fractions together, and we'll get x over 8. And then we've got 1/2 times another half times 1 over 16. This is 1 over 4 squared, all divided by 2. And when we work this out, we know it's going to be a negative because of this negative half here. So we'll get negative x squared over 128. For our cube term, all of this will come to 3 over 8, and we'll multiply that by x cubed over 4 cubed, and then we'll divide it all by 6. And this will leave us x cubed over 512. And now we just need to expand out this 2. So we'll get 2. The 8th times the 2 will give us x over 4 minus x squared over 64 plus x cubed over 256. And this will be the expansion for the square root of 4 plus x. Okay? And this will carry on. For part B, state the values of x for which the expansion is valid Well, we're told here that this is valid when the magnitude of x is less than 1, but our x term was x over 4. So it's this magnitude which has to be less than 1. We can move this division of 4 to the right-hand side, so the magnitude of x has to be less than 4. But x can be positive or negative. So our expansion is valid when x is less than the 4, but greater than negative 4. Okay? Let's try another question. So in example 2, we need to find the first 4 terms of this expansion, and then to state the values of x for which the expansion is valid. So do you want to give this question a go yourself? You need to begin by identifying the n term and what x will map onto. You can pause the video and come back. Okay, so I'll come back if you had a go. So if we write this as a power, I'll write this constant term first. So we'll have 3 plus 2x raised to a power of negative 1. And then we need to factor out this positive 3 because we need the constant term to be 1. So we'll have 3. We'll need to multiply this by 1. And what do you think the x term needs to be to leave us with 2x? So this will be 2/3 of x. Because when you expand this out with a 3, these two will cancel. And this is all raised to a power of negative 1. So then we need to expand out this negative power. So we get 3 to the negative 1 multiplied by 1 plus 2 over 3x to the same power. And we know 3 to the negative 1 is just 1/3. So this is 1/3 multiplied by 1 plus 2/3 x to the power of negative 1. So this is where we'll focus for the expansion. What do you think our values of n and x will be? So n will be negative 1, and x will map onto 2/3 x. Then we can substitute these values into our expansion. So we'll have 1/3, we'll have a 1 term, plus n, which is negative 1, multiplied by x, plus n, then n minus 1, and then the x term squared, divided by 2 factorial, which is just 2. And then for our next term, we've got n minus 1, and n minus 2, multiplied by the x term cubed, divided by 3 factorial, which is 6. So now we can tidy up each of these terms. We'll have 1/3 multiplied by 1. This will become negative 2/3 x. You can see that this 2 will cancel with this one, and then we'll have negative 1 times 2 over 3 squared. So this will be plus 4 over 9 x squared. And then for our next term, we've got the positive 6 here divided by this 6. So these will cancel. We'll have this negative 1. Then we'll have 2 over 3 cubed. So this will give us negative 8 over 27 x cubed. Okay? So what do you think we need to do next? So now we need to expand out this third. So 1 over 2x plus 3 will be approximately the third times the 1, the third times negative 2/3, and then multiplied by the 4 over 9, and then the negative 8 over 27. Okay? And then for the values of x for which the expansion is valid, well, this is valid when the modulus of our x term is less than 1. So the modulus of x must be less than 3/2. But we know this can be a positive or a negative, so this is when x is less than 3/2, but greater than negative 3/2. Okay? Well, thank you for watching. You can now download the worksheet or view the online lesson on my website.